Hello my dear friends and welcome to our today's class. It's our fourth lesson on the fourth topic of Form 3 work, which is called Work, Energy, Power and Machines. As usual, let me commence by giving you the quote of the day, which states that failure stops the moment you start pushing yourself to improve. We shall discuss that quote at the end of our class today. So today we are looking at the pendulum. Remember, a pendulum is just a bob which is tied on a thread or on a string. Then it is suspended freely in air. So this is our bob, this is our string. So we have suspended our bob to hang freely in air, which forms what we call a pendulum. So at points A and C, the pendulum bob has maximum potential energy, because we know that potential energy is given by mgh, that is mass of the body times gravity times the height, that is the height from the ground level. So if this is our ground level, then when the bob is at point A, it is at the maximum height from the ground level. Also remember, the bob swings from point A to point B, then to point C, that forming half an oscillation. Then it swings back from point C to point B, back to point A to complete one complete oscillation. So as the bob swings from point A, that is when the bob is at point A and at point C, you can see that at point A, the bob is at a maximum height h from the ground. Also at point C, the body goes into a state of rest before it swings back. Therefore, also at point C, the body or the bob, that is the pendulum bob, moves to a maximum height from the ground. So you can see the height h from the ground. So because gravitational potential energy is given by mass of the body times gravity times the height of the body from the ground, therefore it means that at the point where the body has the maximum height from the ground, that is when h is maximum, that will give you the maximum possible value of potential energy. Also remember that at point A, that is when before the body is released, therefore it is in a state of rest. Also at point C, the body goes to a state of rest before it swings back to point A. So remember, we said that whenever a body is at rest at some height from the ground, then such a body is possessing what we call gravitational potential energy given by mgh, that is mass of the body times gravity times height. So at point A and at point C, because the body is at maximum height from the ground level, this particular ground level, the body is said to be having the maximum potential energy, and specifically in this case we are talking of maximum gravitational potential energy. At the same points A and C, the kinetic energy is minimum or simply zero. The reason being, when the body is at point A, the body has not begun swinging, therefore it is in a state of rest, that is before it is released. At point C, the body swings to the maximum position, it goes to a state of rest before it swings back. Therefore, the body at point A and at point C, the body is actually at rest. Remember, if a body is at rest, that one simply means that its velocity is zero. And remember, potential, that is kinetic energy, is given by a half multiplied by mass of the body times the square of the velocity of the body. So because at point A and at point C, the body is at rest, the velocity of the body is zero, and therefore if we substitute in the formula of kinetic energy, V simply becomes zero. So remember, if you take a half times mass times 0 squared, the final answer will just be 0. So at point A and at point C, the body has minimum or zero kinetic energy because the velocity or the speed of that particular body is also zero. However, at point B, the pendulum bob is moving at the maximum velocity. That is, remember, the bob is released from point A. It swings to point B, then to point C. So at point B, actually, the pendulum bob passes with the maximum velocity possible. So because at point B, the body has maximum velocity, and we know that kinetic energy is given by a half times mass of the body times the square of the velocity of that particular body. It means that when the velocity is maximum, kinetic energy will just take half of the mass times the square of that maximum velocity. So whenever the velocity of the body is maximum, that one simply means the kinetic energy of the body is also maximum. Remember, we said earlier that from our previous class that kinetic energy is simply the energy possessed by a body which is in motion. Therefore, because the velocity of the body is maximum, that is, as the body passes point B, its kinetic energy is also maximum at point B. However, the potential energy at point B is actually minimum or zero. The reason being, as you can see at point B, the height of our bulb from the ground level is actually zero because the bulb is actually on the ground level. So remember, when the height of the body from the ground is zero, that simply means the potential energy also becomes zero, because the potential energy becomes maximum when the height of the body from the ground is also maximum, or when a body is raised at some maximum height from the ground level. So remember, potential energy is given by mass of the body times gravity times the height from the ground level. So when h is 0, that is at point B, you can see my value of h at point B is actually 0 because the bulb is in contact with the ground level. So when h is 0, this formula disintegrates into mass of the body times gravity times h, which is 0. So remember, mass times gravity multiplied by 0, the final answer will just be 0. Hence, the potential energy at point B is actually minimum or simply 0. So this is a graph of that is energy changes for a body falling freely, like in this particular case here. So if we plot a graph of energy in joules against time in seconds, it will be observed that for potential energy, remember at point A, the body has the maximum potential energy because its height is maximum from the ground. So this is the graph that represents the potential energy for this particular bulb, which is swinging. Remember, it is energy, that is energy changes for a body falling freely. So it is released from rest. That is what we mean by a body moving freely, or we are simply talking of free fall. Therefore, in this case, at point A, the body has maximum potential energy because of its maximum height from the ground. As the body swings to point B, actually at point B, the height becomes 0. Therefore, when height is 0, it means mgh. So h becomes 0. Also, the potential energy becomes 0. So you can see this graph at point B, the axis, the energy is actually reading 0. That is, the potential energy at point B is 0. From point B, the body swings to point C, where the height again is maximum. That means that its potential energy also becomes maximum at point C. Then a graph of kinetic energy is represented by this particular graph here. So you can see that at point A, the height is maximum and the body is released from rest. So because at point A, the body is released from rest, so at point A, the body is actually in a state of rest, or it is not moving. That means its velocity is 0. And remember, when the velocity is 0, that one simply means the kinetic energy of the body will also be equal to 0. Therefore, at point A, the body has the minimum or the lowest or 0 kinetic energy. However, as the body moves from point A, swings to point B, at point B, the body passes with the maximum velocity possible. So at point B, actually, the body has maximum kinetic energy, because remember, when velocity is maximum, the kinetic energy also becomes maximum, courtesy of this equation of kinetic energy. So when you increase velocity, when velocity is maximum, automatically you'll obtain a larger or a maximum value of kinetic energy. Therefore, at point B, that is at this particular point B, the body has maximum kinetic energy. From point B, the body swings to point C, again where it goes to a state of rest before it swings back to point A. So at point C, the body is in a state of rest. Therefore, its velocity again becomes 0. And remember, when the velocity is 0, kinetic energy will also be 0. So at point C, the body has 0 kinetic energy. Therefore, this becomes the graph for the body, which is swinging from point A to point C. We can also have energy changes for a body which is projected vertically upward. So remember, if you are projecting a body vertically upward, first of all, you must throw the body, or you must release the body with a force which is greater than its weight. Remember, the weight is mass times the gravity of the body. Otherwise, if you release it with a force which is not greater than its mass and weight, the body won't move upward. Instead, it will move downwards. So actually at point A, the body is released with some maximum velocity in order for it to overcome that is the gravity or its weight as it moves upward. Remember, the weight always acts downwards. So if we start with a graph of kinetic energy for such a body, so at point A, the body is released with some initial maximum velocity. So therefore, when the velocity is maximum, kinetic energy also becomes maximum. The body, as the body moves to up to point B, at point B, the body goes to a state of rest before it falls back. So at point B, when the body is at rest, that means the velocity of the body is 0, and therefore you can see the kinetic energy also becomes 0 at point B. Now from point B, the body now starts moving downwards because of gravity. That is because of its weight, because you know that the weight of the body is its mass times gravity. So the body uniformly accelerates downwards due to its weight and the force of gravity. Therefore, the body moves to point C at maximum velocity. So at point B, the body is at rest, therefore kinetic energy will be 0, courtesy of this particular formula, because velocity is 0. Then the body accelerates to point C, where again it has the maximum velocity because it is moving due to gravity or because of its weight. So at point C, the body has maximum velocity. So when it has maximum velocity, kinetic energy also becomes maximum. So you can see at point C, the body has maximum energy or maximum kinetic energy from this particular curve here. Then let's look at the graph of potential energy for the same body. Remember, the body is released from point A at the maximum velocity, and therefore it is also being released from the ground level. So if you are releasing from ground level, it means the height is 0. And remember, when h is 0, potential energy becomes 0. Therefore, at point A, because the body is released from the ground, or when the height is smallest, it means at point A, the body will have the minimum potential energy. So you can see the graph is starting from 0. However, when the body gets to point B, it is at the maximum possible height from the ground level. So when h is maximum, potential energy also becomes maximum. So you can see as the body moves to point B, the potential energy becomes maximum because the body is at the maximum height from the ground level. Therefore, mgh will give you the maximum possible value. From point B, the body again accelerates back to point A. That is, it goes back to the point C, which is at the same level with point A, which is actually the level ground. So on the level ground, it means that the height of the body from the ground is actually 0. And remember, when h becomes 0, potential energy becomes 0. That is why our graph at point C goes back to potential energy being 0. So those are the two graphs for the bodies. So from the two graphs, we can simply conclude that the law of conservation of energy in this particular case becomes that the sum of kinetic energy and the potential energy of a system should be a constant. So remember, we did say earlier that that is from the principle of conservation of energy, that you can never create energy nor destroy it. Instead, you can only change it from one form to another. So actually, when the bulb is here, it has maximum potential energy. When it comes here, all the potential energy is converted to kinetic energy. Again, when it moves to point C, all the kinetic energy that it had at point B now is converted to potential energy. So you see, if you add the energy at point A and at point B, then you also add the energy maybe at point C and at point B, you will find the same value. Because here, potential energy maximum, kinetic energy 0. At point B, kinetic energy maximum, potential energy is 0. Therefore, if you add potential energy plus kinetic energy for any system that is not being interfered with, then we expect the final answer to be a constant value. Therefore, the law of conservation of energy in the case involving kinetic and potential energy becomes the sum of kinetic energy and potential energy of a system is constant. So sum in mathematics simply means addition. So if you add potential energy and kinetic energy for a system that is not being interfered with external forces, then the sum of potential energy and kinetic energy should give you a constant value, or a value that is not changing. Look at what we call power, and we are saying that power simply refers to the rate of doing work. Remember, whenever we talk of rate in physics, you must put the aspect of time into consideration. Therefore, power will simply be given by work done divided by the time. So the word rate simply denotes the aspect of time. Therefore, power is equals to the work done divided by the time taken to do that particular work. Then the SI unit of power is the watt, which is noted by capital W. It is also important to know that power can also be expressed in joules per second, because we know that the work done, the units for work done is joules, then the SI unit for time is actually seconds. Therefore, we are simply taking joules, we are dividing by seconds. So division means per. Therefore, joules per second are also the other units that we can use to measure power. However, the SI units are simply the watt. Then we have a few conversions. So from this relationship, we can see that 1 watt is equals to 1 joule per second. So 1 joule per second is equals to 1 watt. Then when you have 1000 watt is equals to 1 kilowatt. Yeah, kilo is always associated with 1000. For example, we know that 1 gram is equals to, that is 1000 grams is equals to 1 kilogram. So kilo is always associated with 1000. Then mega is always associated with million. So a million watt is equals to 1 megawatt. 1 megawatt. So megawatt are simply the larger units of, that is the units that we use to measure a large amount of power. Then we are saying that power is equals to work done divided by the time taken. So we can also express the power in terms of the force, distance, and the time taken, or the force and the velocity. So remember, work done is equals to the force, the product of the force and the distance moved as a result of that particular force. Then we divide by the time taken. So remember, force times distance, that is simply the definition of work done. That is the product of the force and the distance moved in the direction of that particular force. Because we did say earlier that work is only done when a force causes a body to move some distance in the direction of that particular force. So if I break this formula, force is simply denoted by capital F, distance we denote it by small d, then time taken we denote it by small t. Therefore, we know that distance divided by the time taken, or displacement over time taken, that is the definition for velocity or speed. Therefore, we are seeing that power can also be expressed as force times velocity, or force times the speed. So power is also equal to force, the product of the force and the velocity of the body. Then I have one example here that I want us to look at. So the example is that a person weighing 500 newtons takes 4 seconds to climb upstairs to a height of 3 meters. So we are asked to find what is the average power in climbing up the height, that is the height. So we know that power is equals to work done over time. So we just look at what we have been given. In this question, we are given the weight, which is just the same as the force. Then we are also given the time t, which is 4 seconds. We are also given the height, which is the distance in this particular case. So power is equals to, the work done is equals to force times distance divided by the time taken. So we are given the force, or the weight of the body, is 500 newton. Then the distance moved, or the height moved, is 3 meters, because remember, work done is force times the distance moved. Then the time taken to do that particular work is 4 seconds. So divided by 4 seconds. So if you compute this calculation, you'll obtain 375 watts. So I also have an exercise here that I do recommend that you should try at your own free time to gauge whether you have understood this example that we have just done up there. Then of course, if you have any challenges in handling any of the questions given in the exercise, feel free to drop a comment specifying the nature of your problem, and of course, I'm always here to try and help where possible. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that failure stops the moment you start pushing yourself to improve. So the quote is reminding us about the importance of pushing ourselves to the limit of our potential. It is also encouraging us to take small, positive, consistent steps which are aimed at improving our general well-being. And lastly, recall that a winner is someone who failed at something several times without giving up. Therefore, in order for you to win something, you must first stay consistent in your actions. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Thank you very much. Until next time. This is a Kind Tuition Academy. Kind Tuition Academy.